This video is over lesson 77, Inequalities with Negative Coefficients, and it is for my pre-algebra classes. So ladies and gentlemen, I recommend that you take a few moments and go ahead and pause the video to copy down the chart here. Make sure you count out and leave some good space there like I've got it. I've got things planned, so please follow that plan. All right, let's dive in and take a look. So first of all, we're starting with, for each one of these, if A is greater than B. And so just understand that we are doing this with a greater than inequality, but you can just as easily do this with a less than inequality. You just switch things around. So B would be less than A. And then in each one of these situations, you would likewise just switch things around. There's really two things we want to look at. And we want to look at, after the and, is whether C is positive or C is negative. And so what we're going to do here is we're going to take our inequality and we're going to say, all right, if C is positive, then, and we'll continue it down here, then what happens when I have A plus C and I compare that with B plus C? So let's take a look. So over here, if I've got four inequalities all identical here laid out. So if I come through and let's say we just add 2 to both sides. So let's make our C 2. So if I add 2 to both sides, 8 plus 2 is 10, and a negative 10 plus 2 is a negative 8, and this is still greater than. Still greater than. So what we see here is if we started with a greater than, and it doesn't quite prove it, but it suggests it, but I'll let you know it's correct. It turns out if you add a positive to both sides of your inequality, it'll stay the same inequality. So what I'd like you to do right now for me is grab your yellow highlighter, and we're going to kind of keep track of this here. We're going to highlight that yellow highlighter, and since this stayed the same, we're going to go ahead and highlight that in yellow as well. All right, and we're going to work our way down. So we're going to stick with the positives here. So next, if C is positive, we're going to look at what happens with subtraction. So if I come back over here to my board, so I'm going to subtract a positive. So this time, let's subtract a positive 2. So 8 minus 2 would be 6, and a negative 10 minus 2, so if I go further down in the negatives, would be a negative 12. And so which is bigger? Is it bigger to have $6 or bigger to owe somebody $12? Well, obviously it's greater than to actually have your own money. So once again, if C is positive, then when I subtract something on both sides, the inequality will stay the same. So grab that yellow highlighter again. All right, we're going to move on to multiplication then. So what happens if I take my C then, my positive C, and multiply it on both sides? So down here, to show that properly, I would need to do 2 times 8 and a negative 10 times 2. And then 2 times 8 would be a 16. A negative 10 times 2 would be a negative 20. And so these would both still be greater thans. It's still more to have $16 than to owe somebody $20. So this will stay the same, and I'm going to grab my yellow again. So nothing's changing there. All right, last one, we're going to divide both sides. So what happens then if I take that C and I divide both sides by C? That positive C. So again, I'm going to reuse 2. So I'm going to divide both sides here by 2. So 8 divided by 2 gives me a 4. A negative 10 divided by 2 gives me a negative 5. And sure enough, it's still the same. So I'm going to write in that greater than, grab my yellow again. So it turns out, ladies and gentlemen, if what we are doing to both sides is a positive number, it has no effect on our inequality. If the inequality was a greater than to begin with, it'll still be greater than. If it was a less than to begin with, it will still be less than. So now let's take a look at what happens when we have a negative. So if C is a negative, what happens when I add on both sides? Well, ladies and gentlemen, consider if you add a negative, isn't that really like just subtracting 2? For that matter, if we subtract a negative, minus a negative would be the same as plus a positive 2. So it turns out that adding a positive is the same as subtracting a negative. So therefore, this would stay the same. And for that matter, subtracting a positive is the same as adding a negative. So what we further see here, ladies and gentlemen, is that if C is positive, if what we're doing to both sides is positive, it has no effect on the inequality. If we're adding or subtracting on both sides, it has no effect on the inequality. Now let's take a look at multiplication. So now if I look over here at my multiplication problems, this then would be a negative 2 and a negative 2. Well, a negative 2 times 16 would be a negative 16. A negative 10 times a negative 2 would give me a positive 20. And now, is it more to owe somebody $16? Or is it more to have your own $20? Well, obviously, that has changed. It would be more to have your own $20, which means that this also would be more. And so, what we see here is that if what we're multiplying both sides by is a negative, then actually the sign will change. So we're going to write a less than there. And I'd like you to grab your orange, please. I'm going to highlight that in orange. If we multiply both sides by a negative, it will change the sign. All right, last one here. So what happens if I divide both sides by a negative? So if I look at my board here, so this time we're going to divide by negative 2 on both sides. So a negative 8 divided by a negative 2 would give me a negative 4. A negative 10 divided by a negative 2, these two negatives would cancel, giving me a positive 5. So is negative 4 greater than 5? Obviously not. It would be more to have 5 of my own dollars instead of owing somebody else 4. So likewise, with division, it turns out if we divide by a negative, our inequality will flip. So ladies and gentlemen, to sum up this whole chart here, what you need to see and realize is that if you add or subtract on both sides, it has no effect on the inequality. If you multiply or divide by a positive, no effect on the inequality. The only time the inequality will change is if we are multiplying or dividing by a negative. So with that being said, we're going to take a look at some just simple one-step examples of inequalities, and we're going to do some solving. And our first one will be x minus 2 is less than 7. So obviously to get rid of a minus 2, we're going to add 2 to both sides. Now remember, with addition, it doesn't matter what we add, it's always going to stay the same. So if this was a less than before, it's going to be a less than still. So I'd like you to please go ahead and take out your yellow, and we're going to highlight the plus 2's there. Plus 2 is not going to change the sign. So then this is still going to be, I'm going to highlight that in yellow, x, and then 7 plus 2 is 9. And there's my solution. Let's say I have x plus 8 is greater than or equal to negative 5. Greater than or equal to negative 5. I'm going to solve this just like an equation. I'm going to do things to both sides. So to get rid of plus 8, we're going to do minus 8 on both sides. Now remember that subtraction does not change the symbol. So when we subtract 8 here, it's going to be no change in the symbol. So if it was a greater than or equal to before, it's going to be a greater than or equal to after as well. So simplifying this, x then is greater than or equal to negative 5 minus 8 would be a negative 13. All right, moving on. So we're going to do 2/3 x is greater than 6. 2/3 x is greater than 6. So ladies and gentlemen, remember that in order to cancel out a fraction that we're multiplying by, we do not divide by fractions, we multiply both sides by the reciprocal. So I'm going to copy down my problem, and I'm going to multiply both sides by the reciprocal of 2/3. So I'm going to multiply both sides by 3/2. So we need to consider here, what did we just do? Well, we multiplied by a positive. So if we multiply by a positive, we're in the yellow. That means that it is not going to change. Whatever the inequality was before, that's what it's going to be after. So this will still be a greater than. And then let's simplify. So obviously the reciprocals will become a 1, and 1x is just x. Still a greater than. And then here, remember that when you multiply a fraction with a whole number, or a whole number with a fraction, you can treat the denominator as if it were something to divide by, and then the numerator as if it was something to multiply by. So 6 divided by 2 is 3, times 3 is 9. So x must be greater than 9. I'm going to come over here. X over 4 is greater than a negative 7. So this time, I'm going to look at this and say, okay, fractions mean division, so this is really x divided by 4. So to cancel out a divide by 4, I'm going to have to multiply both sides by 4. So again, it's a multiplication to solve, so I'm going to copy this down, and then on both sides, I'm going to times by 4. So again, consider, what do we do here? Well, we multiplied both sides. And what do we multiply by? We multiplied by a positive, so it's still going to stay the same. So my times 4 here and my times 4 here, well, that was a greater than before. It's still going to be a greater than afterwards. Now to finish it off, simplify that, that'll just be x is greater than, and a 7 times 4 is 28, but it'll still be negative. Now that's going to be a place where I see a lot of errors happen, is because we have a negative here. A lot of students are tempted to go ahead and flip the sign. But remember, ladies and gentlemen, the question you have to ask yourself here is, what are you doing to both sides? So what I did to both sides was I multiplied by a positive. That's what happened on both sides. It didn't matter that there was a negative already here. What matters is, what are we doing to both sides? So my answer, x is greater than a negative 28. All right, and one more. We're going to take a look at a negative x over 4 is greater than a negative 7. So very similar to the last one. This time we've just got x over 4, but it's negative. So to cancel that out, I'm not just going to multiply both sides by 4, but I'm going to multiply by negative 4 to cancel out the negative as well. So I'm going to put this in parentheses just to make sure that that negative is grouped with that 4 in that fraction. And then for good measure, I might as well just go ahead and do the same thing there. On the other side, I might as well be consistent. And so a negative and a negative will cancel. A 4 that I'm multiplying by will cancel with a 4 I'm dividing by. That'll leave me with just x. On the other side, a negative 7 times a negative 4. The negatives will cancel, and 7 times 4 is 28. So, but what symbol are we going to have here? Well, what are we doing on both sides? On both sides, we are multiplying by a negative 4. So grab your orange, because when we multiply both sides by a -4, that is going to flip our sign. So if it was greater than before, now it's a less than. So this will actually be x is less than a positive 28. Moving on, we'll take a look. We've done some addition, we've done some subtraction, we've done some multiplication now, so let's take a look at some division. So for our first example, 7x is less than or equal to 42. So for here, we're going to go ahead and get rid of that 7 by dividing both sides by 7. So ask yourself, what have we done? We divided by a 7. What kind of 7? Well, since it's a positive, that means the sign will stay the same. So it will still be a less than or equal to. So over here we'll have x, and then 42 divided by 7 is 6. 7x is less than or equal to a -42. So once again, what do we need to do to solve this? Well, we got to divide by both sides by a 7. What kind of a 7? A positive 7. So since it's positive, we're still in our yellow. So I'm dividing both sides by 7 again. So that means there will be no change, once again, to our inequality. And so therefore, x, though, this time, so -42 divided by 7 will be a -6. And then finally, what if I have a -7x is less than or equal to a -42? Well, to get rid of the -7 there, I'm going to have to divide both sides by a -7. And so I'll end up with x, and then a -42 divided by -7 is a 6. And again, this is where a lot of students will want to make mistakes. What I often see is students looking at this and saying, oh, well, this ends up being positive, so therefore the inequality will stay the same. But if you say that, you're not asking the right question. Remember, the question is, what are we doing to both sides? Not what's the result, not what was there before we did anything. We're asking, what are we doing to both sides? And so when we divide by a negative, it is going to switch our sign. So dividing both sides by a -7 will switch that to becoming a greater than or equal to. So those are all just one-step inequalities, solving those. We're going to take a look now at just a couple of two-step inequalities, or I should say a few two-step inequalities. So here we go. First one will be a -3x minus 10 is greater than 8. And ladies and gentlemen, we're going to solve this the same way we would solve an equation. So we're going to follow our SADMEP. So first things first, I'm going to take care of my -10 by adding 10 to both sides. Now remember, ladies and gentlemen, that addition never changes the sign. So it doesn't matter what we're adding to both sides, because addition will always leave it the same. So if it was greater than before, it will still be greater than afterwards. So simplify this, my -10 plus 10 will cancel. So I have a -3x, and then 8 plus 10 is 18. Next step, we want to get rid of our multiplication now. So we're multiplying by a -3. So to cancel out that, we need to divide by a -3. Remember, the only time the sign changes, the inequality sign changes, is when we multiply or divide by a negative, which is exactly what we've done here. We have divided by a negative. So therefore, my greater than will turn into a less than. And simplify, this will turn into x. And then -18 divided by -3 is a -6. So my solution there is x is less than -6. Let's go ahead and go next to this. 4x plus 9 is greater than or equal to 5. So SADMAP, the first thing I'm going to take care of is addition and subtraction. So I'm going to subtract 9 on both sides. Remember that subtraction, it doesn't matter what you do. Anytime you subtract, it will always end up being the same. So it'll still be a greater than or equal to. So simplify this, I got a 4x, and 5 minus 9 is a negative 4. Now to get rid of my times 4, I'm going to divide both sides by 4. So division, we got to think, is it positive or negative? Well, I'm dividing both sides by a positive, which means that my sign will stay the same. So it'll still be a greater than or equal to. So therefore, x is greater than or equal to negative 1. So this time, the inequality did not change at all. It stayed the same all the way through. For our next example, we're going to go ahead and look at 50 minus 50x is less than or equal to 30. So SADMAP would tell us to first take care of any subtraction or addition we have. So we're going to have to take care of this 50 first. And this is another place where students often make mistakes because we see the minus sign and say, okay, well, we must need to add 50 to both sides. But ladies and gentlemen, remember, the closer we get to algebra, we need to start thinking about this minus sign as really being more of a negative. So it's a negative, though, that applies to this 50x. So if we add 50 to both sides, then you'll have a positive 50 plus 50. That does not cancel. That would make 100. So instead, since this is a positive 50, we want to subtract 50 on both sides. So my positive 50 and my basically negative 50 will cancel. Now remember that this minus is a negative with that. So this will be a negative 50x left over. And then 30 minus 50 would be a negative 20. Well, what kind of sign? Well, remember, subtraction, it doesn't matter what we subtract on both sides. The inequality will always stay the same with subtraction. So it's still going to be less than or equal to. Now if we finish it off, to cancel out my negative 50 I'm multiplying by, we will have to divide both sides by a negative 50. And so when we divide, we need to consider, is it positive or negative? Well, this time it's negative. So that will flip my sign. So instead of being less than or equal to, now it's going to be greater than or equal to. Now obviously the negative 50 I'm multiplying by will cancel with the negative 50 I'm dividing by. So that's just x now. Over here, the negative and the negative will cancel, so this is like 20 over 50. Well, that's easily reduced down to 2/5. So x is greater than or equal to 2/5. And we're going to go ahead and take a look at one last example. Last one. A negative 5 times the quantity x minus 3, close parenthesis, is greater than a positive 5 times the quantity x minus 3. All right, and here we go. So first things first, noticing that I've got those parentheses there, I want to get rid of them. So one of the first things I'm going to do is I'm going to simplify. I'm going to simplify here by using the distributive property. So remember that the distributive property works when we have multiplication outside and then addition or subtraction inside the parentheses. And so what we're multiplying by outside will go to each of the things we are adding or subtracting. So that means this negative 5 will get multiplied with x, and this negative 5 will get multiplied with negative 3. I'm going to treat that as a negative. That minus 3 will be like a negative 3. So when I do that, a negative 5 times x gives me a negative 5x. Then a negative 5 times a negative 3, negative times negative cancels. That'll be plus 15. Over here, likewise, we're going to distribute that 5 into each of these. So 5 times x will give me 5x. And then 5 times a negative 3 will be a negative 15. So what symbol do we have here? Well, actually, this is neither our yellow highlighter nor our orange highlighter, because remember, the highlighting here has to do with what have we done to both sides. And in this case, there is nothing we have done to both sides. We just used the distributor property on one side, and then we used it again on the other side. But this is not something we've added to both sides. This was not something we multiplied on both sides. So it has no effect on the outcome. So the symbol is the same because no add, subtract, multiply, or divide on both sides. We didn't add, subtract, multiply, or divide on both sides. We just simplified. Now, though, I'm going to go ahead and I'm going to take a look at how to solve this further. So notice that we have an x on both sides. That's something that we don't like. But what separates my x term from my constant term is addition and subtraction. So as far as SADMAP is concerned, it's going to be addition and subtraction that allows me to cancel out one of those x terms that we don't want anymore. So if I don't want an x over here on the right side anymore, let's cancel it out. So positive 5x will be canceled with a minus 5x. So I'm going to minus 5x on both sides. So negative 5 minus 5. So if you're $5 in debt and you go $5 more in debt, that's a total of $10 in debt. So we still have a plus 15 there, and the minus will make this like a negative 15. So I got ahead of myself a little bit here. But remember that anytime we subtract, it doesn't matter what we're subtracting by, the inequality will stay the same. Moving forward, we still have more addition and subtraction to take care of, because now that I've got all my x's together, I need to get rid of this plus 15. So it'll be time to subtract 15 on both sides. And so I'll have a negative 10x left over there, and then negative 15 minus 15. So we'll go 15 to the left, and then 15 more to the left. That's a total of 30 to the left. Remember, though, that subtraction, we just did this a second ago. Subtraction doesn't matter what you subtract by. The inequality sign does not change. So that'll still be a greater than. And finally, to finish it off, we're done with the SA part of SADMAP. We're going to move on to the DM part and divide both sides by a negative 10 to get rid of that negative as well. So this time, a dividing by a negative is one of the two times that our inequality flips. So now it'll be a less than. So x is less than, and a negative 30 divided by negative 10 is a 3. So x is less than 3. And ladies and gentlemen, that is our lesson.